Wow, look at that. Lasers. Blur infrared device.
Hi everyone, this is Xenon.
What up, fam? Today we're going to talk about noble gases. Not only talk about them, we're also going to play with them because, in addition to just looking them up online, I have also recently acquired a Tesla Coil. I have acquired a very powerful magnet and the noble gases themselves, plus a laser, very powerful green laser, because lasers are fucking awesome. What are noble gases? So, on our periodic table, so standard periodic table, over here on the far right side, these are our noble gases. What makes these gases noble? 'Tis the question, and a valid one. One of the reasons that they're considered noble is that they are seen unique from the others in that they all have 8 electrons in their outer valence shell in differing densities here, depending on the atomic weight, with the exception of helium, that only has 2, but is also considered a full and balanced and not in a desire to give away electrons or in a need to take any on. So they are stable in their own right. They're monatomic acids, so they are single in their atomic form. They don't need to combine with other atoms to make elements or to make up a molecular structure. Low boiling melting points, their densities increase as they go on. They are colorless, odorless, and tasteless in their natural state. Something that's actually pretty cool with gases, these inert noble gases, is that you can actually inhale them. Many of us know what helium sounds like when you inhale helium, but do you know what it sounds like when you inhale the others?
Here goes.
Alright everyone, this is helium.
Alright everyone, this is neon.
Alright everyone, this is argon. Alright everyone, this is krypton. Alright everyone, this is xenon.
Alright everyone, this is a few atoms of radon.
So that one is, radon is radioactive, and he actually couldn't get in a gas form, so he was just sniffing the molecules of the radium composite there. So yeah, as you can see, the different densities actually bring down the voice, the way it vibrates through our vocal cords, which is crazy. It's wild. So here's some other periodic tables that are interesting. 1920, the Schaltenbrand's heliotic periodic table. And this is the way he designed it. And what's interesting about this one, as we can see as we go down the tree here, is that our specific elements even. So we've got helium right at the center here. Then we've got neon, argon, krypton, xenon, and radon down here. And they're all kind of on the out of the right side, it looks like to me, of the center spiral where it would be. Because helium would be like down a center spiral kind of, right? And those are all off to this side. Anyway, that's cool TV or periodic table to look at. And then it looks like, I think in 2019, someone made, look at this, they actually had this commissioned to be made. Now, what would be cool is if it actually had every element, you know, little tiny piece of every actual element in there, which I'm not sure if they do, because like how would you, I mean, I guess if you contain the gases and stuff inside, I don't know, that'd be pretty cool. So we also got the spiral periodic table, 1960. You can see our noble gases are all right here. Got another spiral periodic table, and our noble gases again are right here. There's some other really great ones as well by Walter Russell back in 1926 was his original creation of this periodic chart. Now, what's cool about this is he split up into octaves. And so he's got 9 octaves on here, and you can see for our gases, they're all in the center, looks like, of these octaves, or in between each wave, in between octaves, right? That balance or center point, at least the way this is structured. So helium, neon, argon, all in the center here, krypton, xenon, and then he called this niton. So I don't know if they were calling it back then that, or it wasn't sure what the deal is. That's what he's calling it. That's what we know as radon nowadays. And he also articulates out almost subatomic dynamics here. So, because even below hydrogen, where it gets down to a gammanon, a betanon, and an alphanon. And we do have asterisks on that, which usually means there's notes. Here we go. Stars indicate elements discovered by Walter Russell. Okay, so these are ones that he's identified. So it'll be interesting to see how those will correlate with things we've learned since then. That's a great one for Walter Russell's. We also have... Here's another one of his. This is actually a little more updated, so it does show radon here. And Omega Non for element 118. That was unrealized. That was before it was created. I think in either... I saw two different ones on that with two different names. One 2002 and then another one that they created, but it's very unstable and doesn't last very long as a gas. And so, yeah, and this spirals out too, the way they show this, right? So you got zero motion, and then those three that he articulated out as pre-hydrogen. They got hydrogen, helium, neon, argon, krypton, xenon, radon, omega non. Another cool periodic table. I actually really like this one because this is the emission spectra of elements. This is spectroscopy, so you can actually see the colors spectrum that each of the elements make. And I think that is super awesome. So I really like that. So here's our gases over here on the far right. These guys. And it's interesting. Look at argon. Look at the amount of light spectrum it looks like you can engage with it versus these other ones, especially radon. And these other ones, there's no actual light visible emission spectrum, it looks like. But there is for all these others, as we'll see here when we start playing with those. Here's another one by Walter Russell that apparently May 16th, 1949, Life magazine. I don't know if that's true, but that'd been pretty cool if he was in there. What's interesting about this one too, you can see our noble gases are all right here in this spire, and then he's got this set up for all the others. Check that out. This one might be Victor Schauberger's, but I can't quite tell, and I can't really find one. So he's another dude. I think Schauberger's brought up during Paperclip as well. But yeah, there's not even... If there are words here, you cannot read them. Okay, that's it for a decent overview of noble gases. Now we're going to actually playing with them. I'm going to take you over here to my desktop, and let's fucking go. Mobile camera setup. Turn this on. So as you can see, we've got the same order as the bottom: helium, neon, argon, krypton, xenon. And obviously, as we get different distance away, some are more or less reactive. Xenon's still lit up a little bit, so is helium. Okay, so one of the things I'm going to do here, I'm going to show you, when we touch them, you can see the effects of adding just my body to the equation. It's cool looking. It's super blue. It's interesting. It goes from that green haze. It's like super white blue on top, and that goes to like a purple. So does that. It goes even more orange. It's another white. Alright, so we're also going to take this magnet here. Let's get on the camera. So here's our big 500-pound magnet, and see what we can see. Now, I have played with this a little bit before, so what I've noticed... You see that halo up top? You're gonna get that. And see that? See, it's kind of connecting that plasma. It definitely does that for helium and neon. Real nice. Like it wants to create a ring, some kind of plasma ring. Argon, not so much. Krypton a little bit. Xenon a bit. But none of them have a distinct ring or almost a desire to engage, if you will. Like helium and neon. So I'm also going to start playing with these one at a time. Okay, I'm going to start with helium. Now, when we actually touch the arc, it super ignites the plasma in there, because from a distance, it kind of evenly ignites it in the tube, but then it super condenses the focus there. Now, when we put the magnet on, and now moving in a circle, well, you can see, yeah, away and towards and around, so like 360 degrees. Horizontal to the ground. And you can see that this is like the desire, for lack of a better word, for that plasma arc to be connected, and or the ability to manipulate that plasma. Right? And if we go up the scale here, so let's go neon. There's a similar dynamic. It wants to keep that center plasma connected or touching or moving with the magnet, but not quite as readily as the helium. Here's our argon. You can tell it affects the plasma cloud around it, but it's not creating that same stream of plasma that it so easily does with the other ones. Move on to krypton. So cool looking though, either way. It's really cool. And xenon. Xenon's got that cool green milky haze almost to it. Except where it's touching my fingers on the glass, and it's all lit up in kind of a white purple. But you can definitely see the magnetic field effect, you know, regardless. And as long as I don't get if I get close, and it creates a connection point even through the glass. Let's go right into there. Wow, look at that. Look at the ripples around the edge of the field there. Those are cool looking. Go back for contrast all the way back to helium. Definitely effect on the field, but it wants to connect that center plasma. Look at that, I'm not even touching it. Awesome. Now, for the laser part. And this isn't going to get us any effect reaction with the plasma, really. It just looks really fucking cool. Because lasers. With this magnet, here's an actual orientation tool that shows you the direction a magnetic field is oriented. And so as we approach the magnet, it's going to orient that way. So the north polar field is facing that way. that's it for me today, folks. Here's been a fun update playing with plasmas and lasers. Definitely more to come in the days ahead. Please feel free to like, subscribe, leave comments, do all that fun stuff to be able to engage in more conversation and more physics and plasma and universal awesomeness. Laters.